One of the things that we're able to do with integration is to solve what we call a differential equation. And in a differential equation, you're given some information about the rate of change of a function, and you find the original function. So in its most simplest form, you're given the derivative of a function. So let's say you're given f prime of x, and you need to find f of x. So we know that if we integrate f prime of x dx, we are given the original function f of x plus c, and this is our what we would call our general solution. If we are given some piece of information about the original function called an initial condition, we can find the actual original function, or what we would call the particular solution. So let's do an example of each one of those. So let's say I'm given f prime of x is equal to x squared plus 3, and I want to find f of x. So I'm going to integrate x squared plus 3 dx, and that will give me 1/3 x cubed plus 3x plus c, and that's what I would call my general solution. Let's say I'm given that f prime of x is equal to x squared plus 3, but I'm also given that f of 3 is equal to 22. So this is what I call my initial condition, and I can use the initial condition to find the value of c. Our constant of integration. So we'll start with integrating x squared plus 3 dx. And as we saw, that gives us 1/3 x cubed plus 3x plus c. And then we will use the information f of 3 is equal to 22. So we're going to substitute that into our antiderivative and find the value of c. So this is what I know then. 22 is equal to 1/3 times 3 cubed plus 3 times 3 plus c. And so this gives me 1/3 of 27 is 9 plus 9 plus c equals 22. So that 18 plus c is equal to 22. And so subtracting 18 from both sides gives me c is equal to 4. C is equal to 4. So I know then that my particular solution is 1/3 x cubed plus 3x plus 4. I should say f of x is equal to. Let's go over one more example like that. Let's say that f prime of t is equal to secant squared t plus 2 cosine t. And then I'm also given that f of pi over 4 is equal to the square root of 2. That's my initial condition. So I'm going to integrate secant squared t plus 2 cosine t dt. So this is the first time I'm using a different variable. Notice that instead of dx, I'm using dt here, and that's just saying integrate with respect to t. And so the integral here, the integral of secant squared t is tan t, and the integral of 2 cosine t would be 2 sine t plus c. And now I can substitute in my initial condition, and I have tan of pi over 4 plus 2 times the sine of pi over 4 plus c is equal to the square root of 2. So what I know, the tan of pi over 4 is equal to 1 plus 2. The sine of pi over 4 is radical 2 over 2 plus c equals square root of 2. And so I have 1 plus the square root of 2 plus c is equal to radical 2. And solving for c will give me c equal to negative 1. And so my particular solution then will be f of t is equal to tan t plus 2 sine t minus 1.